Hello students, I am Dr. Anita Sharma. Welcome in my chemistry class. Today I am going to start a new topic of chemical bonding, that is preparation, properties and structure of diboranes. So let's begin. Chemical bonding, paper number 302, semester 5. In this lecture we will learn preparation, properties and structure of diboranes. This is the structure of diborane. So the binary compounds of borane and hydrogen are called boranes, and it was first prepared between 1912 to 1936 by Alfred Strock. And boranes are the name of class of synthetic hydrates of boron. Many boranes synthesized from thermolysis of B2S6, and the most important thing, all boranes are diamagnetic and colorless. The parent member BH3 is called borane, and it founds in the gaseous state and it dimerizes to form diborane, that is B2S6. The boron hydrates can be represented by general formula BnHn plus 4, where n is equal to 2, 5, 6, 8, 10 or 18. And second formula BnHn plus 6, n could be 4, 5, 6, 9 and 10. But the boranes formed by the formula BnHn are quite stable and their melting point is very high. And the boranes formed by this formula are quite less stable and their melting point is also very low. And diborane is the simplest and most studied borane. So now preparation of boranes. So there are three important methods of preparations of boranes. Many more methods are also there, but these three methods are important. So first, it is simplest method, where boron trifluoride reacts with lithium aluminium hydride in presence of diethyl ether, and we will get borane here. So this is simple method. Second method is called laboratory method of preparation of diborane. In this method, this sodium boron hydride oxidized with the help of iodine, and we are getting here borane. Third method is industrial preparation, and in industry it is prepared by reaction of BF3 with sodium hydride at 450 Kelvin temperature, and we get B2S6. So there are three methods. This is the simplest method. This is called laboratory preparation, and this is called industrial preparation of borane. There are some properties of boranes. First is they are highly volatile compounds, and diborane catches fire spontaneously when it is exposed to atmospheric air. It burns with oxygen. The reaction is exothermic, and this much energy is released in this oxygen when diborane exposed to atmosphere. Third, it is readily hydrolyzed with water and gives boric acid. And all hydrates of boron are decomposed to boron and hydrogen on very hot temperature, very high temperature. So if we heat boranes at very high temperature, we can get boron and hydrogen by its decomposition. They easily decompose by alkali also. So here you can see the reactions. So boranes can be decomposed by alkali also. An important reaction where boranes reacts with ammonia and form an additive product, and this additive product when decomposed at 473 Kelvin temperature, here you can see ammonia is reacting with boranes and we are getting an additive product, and it decomposes at 473 Kelvin temperature, and we get B3N3S6 compounds. Name is borazole or borazine. Borazole is also known as inorganic benzene. In view of its ring structure with alternate NH-BH group, borazole contains 3 double bonds and it has 6 pi electrons. So here you can see the structure of borazole or borazine. And this is the example of inorganic benzene, because this structure is very similar to benzene. Here you can see 3 alternate double bonds. So this is the structure of diborane, and X-ray diffraction has shown the following structure of diborane. So here in this structure you can see here the bond angle is 97 between B, H and H, and this is the bond length, HB bond length, that is 131 pm, and bond angle between these two terminal hydrogen and boron is 120 degree. So in this structure, one more time you can see here we have 1, 2, 3 and 4 terminal hydrogens and two bridging hydrogens. Why they are called bridging hydrogens? Because they are forming bridge between this boron and this boron. So two bridging hydrogens we have. And boron atoms in the structure undergoes sp3 hybridization. And one more thing that we have to see, the 4 Ht atoms and 2 boron atoms, means these 4 hydrogens and 2 borons are lie on the same plane, while these 2 hydrogen, which are known as bonding hydrogen, bridging hydrogens, lie above and below the plane. And these are forming, this BH bond is the example of simple covalent bond. And this is not the example of simple covalent bond. So here we will see number of electrons and bond in diborane. As there are 12 electrons and 8 bonds in B2S6 molecule, it is an electron deficient molecule. And due to resemblance of this BHB bond with banana, it is also known as banana bond. Hence, diborane molecule has 2 electron less than the maximum required electron. Thus it is called electron deficient molecule. Means 2 electron less. Otherwise, all the bonds between boranes or diborane would be covalent bond. But this is not the example of covalent bond because of 2 electrons. 2 electrons are less. And these 4 bonds are covalent bond here. So here we will learn the hybridization and bonding in boron. So this is the structure of diborane. In this structure you can see this is boron and these are hydrogen. Since B2S6 is there, so 2 boron and 6 hydrogens are present, and here this boron hydrogen bond is taking the shape of banana. That is why it is also known as banana bond. Now electronic configuration of boron. So this is the electronic configuration, 1s2, 2s2 and 2p1. This is the electronic configuration of boron in ground state. In excited state, the electronic configuration is 1s2, 2s1, 2p1, 2px1, y1 and z0. And in this state, the hybridization is sp3. So in sp3 hybridization of boron, 3 sp3 hybridized orbitals are having 1 electron. Here this hybridized sp3 hybridized orbital is having 1 electron. This is also having 1 electron. This is also having, py is also having 1 electron, but no electron is present in pz orbital. It means out of 4 sp3 hybridized orbitals of B5 or boron, 3 hybridized orbitals are having 1 electron and 4th hybridized orbital is not having any electron. So now we will understand here. We have 4 sp3 hybridized orbitals of boron. Here you can see 1, 2, 3 and 4. And all are having 1 electron. So this 1 electron and the 1 electron of hydrogen, they are sharing with each other and simple covalent bond is formed. Here sp3 hybridized orbital of boron is sharing its 1 electron with this hydrogen. This third sp3 hybridized orbital of boron is forming covalent bond with this. But the problem is this 4th. In 4th hybridized sp3 orbital, boron is not having any electron. So this hybridized sp3 orbital is not having any electron. So here you can see in this boron also. So here we have 2 electrons and 3 orbitals. So 3 centers and 2 electrons. That is why this banana bond is also known as 2 electron 3 center bond. Here also 2 electrons 3 center bond. So these 1, 2, 3 and 4, they are simple covalent bond, and this is not the covalent bond because for the bond to be a covalent bond, the electron sharing should be equal. So in this sp3 hybridized orbital we are not having any electron. Here also the same thing. So this is the structure of diborane. So in short, in diboranes we have 4 terminal hydrogens and 4 simple covalent bond between BH. So BH bond, 4 BH bonds we have and 2 BHB bonds we have, which is also known as banana bond and is formed by bridging hydrogen. Now some applications of diborane. So as a rubber vulcanizer, as a catalyst for hydrocarbon polymerization, it also can be used as a flame speed accelerator. It can be used as a doping agent for the production of semiconductors, and it also can as an intermediate in the production of highly pure boron for semiconductor production. So this is all about diboranes, preparation, properties, structure, etc. And these are the references. Thank you.